Kia ora, and welcome to a lesson on Cambridge Mathematics P2 Integration by Substitution. In today's lesson, we're going to look at how to integrate a complex function by using substitution to make it easier. Okay, so from this you can clearly see the question, use the substitution u equals 2x plus 1 to find the integral of 4x root 2x plus 1 with respect to x. In my equation, I've got the 2x plus 1, so substituting u equals 2x plus 1 to replace 2x plus 1 is going to be easy because this is just going to become u. However, we've got a term here that's just 4x, which we're going to need to get in terms of u, and we've got dx, which we're also going to need to change to du so that we can integrate it with respect to u instead of respect to x. So the first thing to do is to think about how I can get rid of my x. So if I know u is equal to 2x plus 1, all you have to say is u is equal to 2x plus 1, and rearrange this to u minus 1 equals 2x, and x is equal to u minus 1 over 2. So easy replacement. To get rid of the dx, what we're going to do is we're going to differentiate our u equals 2x plus 1 to get du of dx, and then we're going to do a rearrangement of that to find out what our dx term is so that we can replace it. So if u is 2x plus 1, du over dx is just 2, and rearranging this you get du over 2 is dx. So we can replace our x with u minus 1 over 2, and our dx with du over d2, and our 2x plus 1 with just u. So this is what our integral is now going to look like. We're going to have 4 lots of u minus 1 over 2 times root u times du over 2. Okay. Some simplifying here, we've got 4 times a divide by 2 times a divide by 2, which means they're just all going to disappear, leaving us with just u minus 1 times root u and our du. So this is going to become u times root u. So if root u, if you think of u to power half, this is going to become u 3 over 2 minus u to the half. 4 divided by 2 divided by 2 going to disappear, just going to leave us with du. Okay, so now this is much easier to integrate than what we had a second ago. And now we can integrate this in the same way you always would, add 1 to a power, divide by the power. So this is going to become u to power 5 over 2 divided by 5 over 2 minus u to power 3 over 2 divided by 3 over 2 plus c. Some tidying up to be done here with our fractions. So all I'm going to do is change this to 2u 5 over 2 over 5, so 2/5 u 5 over 2 minus 2/3 u to power 3 over 2 plus c. However, this isn't our final answer because our original question wanted us to find the integral of 4x root 2x plus 1 with regards to x. So we're going to need to get it back to our x terms. So we're just going to replace u with 2x plus 1 as it was stated in the original question. So this is become 2/5 2x plus 1 to power 5 over 2 minus 2/3 times 2x plus 1 to power 3 over 2 plus c, and we are done. If it was a definite integral, they would give us some values, you'd substitute them in now to find the area under the curve, but as it just wanted us to find the integral, this is where we stop. Let's have a look at another question. So this is example 2. It says use the substitution x equals 2 tan u to find the integral of 8 over x squared plus 4 with regards to x. So the replacement of x is going to be relatively straightforward because we can just replace x with 2 tan u and then square it. we're going to need to find our dx term, and we're also going to just find this in terms of u, so u equals, so that later on we can replace with substitution to find our final solution, because our integral is going to become something in terms of u, and you're going to want to get rid of that u term. So x equals 2 tan u. Let's get it in terms of u first. So for x equals 2 tan u, then x over 2 equals tan u, which means that the inverse tan of x over 2 is u. Okay, we don't need it right this second, but we're going to need it later. The other thing we're going to do is we're going to find dx over du, so that we can find, so we can place our dx. So dx over du is 2 sec squared u, which means that dx is 2 sec squared u du. So when we come to our integral now, we've got 8 over x squared, which is 2 tan u, so 2 tan u squared, plus 4, and dx is now 2 sec squared u du. So let's do some tidying up. So the 8 times 2 sec squared u is going to become 16 sec squared u, and our bottom is going to become 4 tan squared u plus 4 with respect to du. This is still not something that's easily integrated from this point, unless you identify the fact that we can change 4 tan squared u plus 4 into sec squared u via our trig identity. So the trig identity I am referring to is sec squared u is equal to 1 plus tan squared u. So I can factorize 4 out of this with 4 tan squared u plus 4 to get tan squared plus 1, so that would be sec squared, which means 4 tan squared u plus 4 is equivalent to 4 sec squared u. So this is the integral of 16 sec squared u over 4 sec squared u integrated with respect to u. And again, this simplifies down because sec squared u is going to cancel out with sec squared u. 16 divided by 4 is just going to be 4. So we're integrating 4 with respect to u, which just gives us 4u plus c. Now we can replace our u with the earlier u equals inverse tan of x over 2, which is going to give us 4 lots of the inverse tan of x over 2 plus c. And we're done. Hopefully you followed along with that and can have got some questions yourself now. I'll speak to you again soon.